Hi everyone, welcome to another new video from our channel. This is Shayon. The new video from Bioorganic Hub is from the Fisher projection formula. As I have seen for my students, they feel too much hardship to convert a formula to a Fisher projections formula. Look, the problem is the molecule is a three-dimensional. Molecule has a three-dimensional shape. You have two bonds in plane, or another bonds are in up the plane and below the plane. But you have to represent it in a 2D presentation. So in a 2D presentation, people normally represent in many ways, in among which Fisher projections is one of the convenience way. So how to convert any formula to a Fisher projections, that you have to understand. So first try to figure out what is the criteria of a Fisher projections formula. As you can see here, and Fisher projection formula, this can only applicable for asymmetric carbon atom, means the carbon atom is attached with 4 different groups. So asymmetric carbon atoms is actually will be in the plane of projection. So first point, you have to remember to write any Fisher projection formula of any molecule, that the asymmetric carbon atom which is attached with 4 different groups, you have to represent that asymmetric carbon atom in the plane of the paper, in the plane of the blackboard, or in the plane of the projections. Okay, here in the plane of the laptop, and groups and the top and the bottom will be directed well equally to the plane of the projections. We will see how it's possible. And then automatically group at the right and the left will be directed well equally above the projections, that is the plane of the laptop. We will see by an example, then all the points will be clear. So first point, you have to remember, whenever you are getting a molecule, first try to keep its asymmetric carbon atom on the paper. Then the groups at the top and the bottom should be directed well equally to the plane of the projections. Okay, and next, well equally means the same distance above and the same distance below. That's we want to say well equally to the below and above the plane of the projections. And then automatically other two groups will be directed well equally above the plane of the projections, means on the plane of the projections. Let's see an example. Okay, yeah, so this is very easy. Just don't take any remember don't remember anything. Let's take an example. You have a molecule ABCD. You can see here a molecule ABCD. This is asymmetric carbon atom. Here this carbon atom is asymmetric because A is a different group, B is a different group, C and D is a different group. Now to write the Fisher projection formula, by taking a simple examples of this molecule ABCD, you have to do some steps, 2 steps only. If you follow my rules, 2 steps you have to do only. Okay, in some next video we will also discuss how to write the Fisher projections for a large molecule. Let's say you have a B, C, D, and then another carbon which has also the 4 different carbon atoms that are also asymmetric. So how to write that one, we will see in some later video. First try to find the basics, basics 2 steps to write the Fisher projections. So first, what you have to do, rotations on the plane of the paper. What here is saying, let me take the laser pointer. Yeah, rotations on the plane of the paper. So when you have a ABCD molecule, you first rotate it on the plane of the paper. Why you are rotating? Because you want to keep 2 bonds on the plane and 2 bonds in another plane, let's say below the plane or above the plane. Okay, so rotation on the plane, you just rotate it like this. First you have taken the molecule, and this molecule is like this. You just rotate it like this. Molecule was like this, A B C, A B C below and D above. First rotate it like this. So here will come A, here will come B. That has been represented here. Here it is A and here it is B. So both are A or B on the plane and C and D below and above the plane. As they have said, C is below, D is above. We have not changed anything. Okay. Next, the important step. Now you have this type of molecule on the plane. This is on the plane A, B, and this is D and below C. Now tilt at left. This AB, I just want to open up. This AB has this type of angle. I just want to open up at 180 degree. So like this. you have A, B, and here you have D, here you have C below. You just open up. You just to A, B, you have to open up, make an angle of 180 degree. If you just open up like this, if you just open up like this, here A, here B, then D was here above the plane, D will come here, and C was below the plane, C will go there. That's the simple rule, nothing hardship. Okay, just see again, this was A and B. Now you just have to open up, and you also can tilt around left. You also can tilt around left. See, A, B, D was here, D will come here, C will go there. D will come here and C was here below the plane, it will go there. So again, A, B, here D, and here C. A, this is A, this is B, here D, and here C. Just open up like this, open up like this. D will go here and C will go here. Or if you tilt left, A, B, tilt left, left, left tilt, B will come here, D will go here, and C will go here. That's all. That's a very easy method for the Fisher projection formula writing. And if you follow this, then you not have to worry about. Okay, thank you for watching. Bye.